By default, a program is just a straight road. It runs one command, then the next, in a perfectly boring, straight line. But that's not very powerful, is it? Today, we're tearing up that single road and grabbing the blueprints to build a dynamic, intelligent city grid.
I mean, think about it. A program that can only go in one direction is seriously limited. It can't react to anything, it can't make choices, and it definitely can't repeat tasks without you copy-pasting code everywhere. It might be predictable, sure, but it's not smart.
And that's where you come in. As the programmer, you are the architect. And today, we're going to fill your toolkit with all the essential pieces you need to design complex, branching pathways and super efficient routes for your code to follow.
So what do we call these tools? Well, the official term is control statements. At their core, they're the fundamental building blocks that let you break free from that boring one-way street. They give your program a brain, the ability to make decisions and act differently based on what's happening. Okay, let's pop open that toolkit. First up, decision-making statements. Think of these as your tools for creating intersections, forks in the road, and roundabouts. They let you direct the flow of traffic in your program to all sorts of different destinations.
The most basic tool, the absolute bread and butter of decision-making, is the if statement. It's just a simple checkpoint. It asks a question, and if the answer is true, it runs a specific block of code. And here's a really cool quirk in C. Any value that isn't 0 is considered true. That gives a simple tool a whole lot of unexpected flexibility.
But what happens when you have more than two paths? Well, that's when you build an if-else ladder. It's like a cascade of questions. The program starts at the top, checks the first if, and if it's true, bam, it runs that code and completely skips the rest of the ladder. If it's false, it just moves on down to the next else if, and so on, until it either finds a condition that's true or hits the final else, which is basically a catch-all for if nothing else worked, do this.
Now, let's say your if-else ladder is getting ridiculously long, and all you're doing is checking one variable against a bunch of specific values, kind of like a menu. That can get messy, right? Well, for that job, there's a much cleaner, more elegant tool, the switch statement.
So, as the architect, how do you choose? Well, think of the if-else ladder as your all-purpose adjustable wrench. It can handle anything, complex comparisons, checking ranges, you name it. The switch statement, on the other hand, is like a specialized socket set. It's built for one job, testing a single integer or character against a list of exact matches. And not only does it look cleaner, but it's often way faster, because the compiler can work some magic and turn it into a super efficient jump table.
All right, intersections are done. Now it's time to build the highways and the bus routes that run all day. Our next set of tools are loops, and they are all about making your code do something over and over and over again without you having to write it 1,000,000 times.
Let's start with our first major loop type. As an architect, when do you decide to build with a while loop? The simple answer is, you use it when you have no clue how many times you need to repeat something. A while loop is what we call entry controlled. That means it checks the condition before it runs. As long as that condition is true, it'll just keep on going. It's perfect for something like reading a file. You just keep reading while there's more data, but you don't know how big the file is when you start.
Okay, next up in the lineup is the famous for loop. So what's its deal? When is this the right tool for the job?
You grab the for loop when you know exactly how many times you need to iterate. This is the undisputed champion of definite or determinate loops. And what's so great about it is that it packages everything you need, the starting point, the stopping condition, and how you update your counter, all into one single tidy line of code. It's clean, it's clear, and it's perfect for counting from 1 to 10.
And finally, we have the third loop, the one that's a little less common but has a really unique superpower. Let's talk about the do while loop. What's its special purpose?
This is the key. This is its entire reason for existing. A do-while loop is exit controlled. That means it runs the code inside the loop first, and then it checks the condition to see if it should go again. This gives you a rock-solid guarantee that the code inside will execute at least once. It's perfect for things like a game menu that has to show up on the screen before the player can even make a choice. So, we've built our basic roads and intersections. Now for the really fun stuff. Let's talk about the advanced tools, the jump statements. These let us build in emergency exits, create shortcuts, and, yes, even add teleporters that bend the very rules of how our program flows.
Two of the most important ones you'll use are break and continue. Think of break as the big red emergency exit button. The second your code hits break, it is out of there. It completely terminates the loop it's in and jumps to the very next line of code after the loop. Continue is different. It's more like a detour. It just skips the rest of the current trip around the loop and jumps right back to the top to start the next iteration. The loop keeps going.
And then there's goto. In our city metaphor, goto is a literal teleporter. It lets you instantly and unconditionally jump from any point in a function to any other point you've put a label on. It sounds incredibly powerful, right? And it is, but it comes with a massive flashing warning sign.
This is the #1 problem with goto. It creates what programmers call spaghetti code. And that's not a joke, that's the actual term. Imagine trying to follow a single strand of pasta from one end to the other in a massive, tangled bowl of spaghetti. That's exactly what trying to debug a program filled with goto statements feels like.
And this is precisely why pretty much everyone agrees you shouldn't use it. It completely shatters the nice, logical, structured flow that tools like if and for loops give you. Trying to find bugs becomes an absolute nightmare because the flow can just jump from anywhere to anywhere. And honestly, there's almost always a better, cleaner, more logical way to solve the problem with the other tools we've talked about. So know that it exists, but please leave the teleporter in the box.
So, let's step back for a second and lay all our tools out on the workbench. Let's look at the complete toolkit we've just put together. These right here are the core building blocks for any intelligent, responsive program you'll ever write.
So you see the blueprint, right? You've got your decision tools like if and switch to create all the intersections and choices. You've got your loops like for and while to build those efficient highways for repetitive tasks. You've got your jump statements like break and continue to add those little shortcuts and emergency exits. And the real magic happens when you start nesting these things, putting loops inside of if statements, putting if statements inside of loops. That's how you go from simple parts to an incredibly complex and powerful city grid.
And at the end of the day, that's the real takeaway here. Mastering control flow isn't just about memorizing syntax. It's about learning the fundamental rules of logic that transform a dumb, one-way script into a smart application that can actually adapt, choose, and react to the world. I mean, just think about it. Every single complex piece of software you use, from the operating system running your computer right now to the most mind-blowing video game, is built on these exact same principles: decisions, loops, and jumps. They are the fundamental atoms of program logic. So the only real question left is, with this amazing toolkit now in your hands, what are you going to build?